Hey guys, Dr. Brown here, and tonight we're looking at Algebra 1 work rate problems. Now what is a work rate? It's just work completed per unit time. Work per time. Okay? So let's look at a few examples here. Let's say we have two guys delivering papers. We have David and John. D for David, J for John. And let's see, 30, 60, 90 minutes. So David, he can deliver 100 papers, P for papers, in 60 minutes. M for minutes, okay? 60 minutes. John can deliver 100 papers in 90 minutes. 90 minutes. So if you look at the work rate of David, it would be 100 papers, so that's the work completed. He delivered 100 papers in 60 minutes. So let's reduce that. So we have 10 papers over 6 minutes, and 10 is 2 times 5 papers over 2 times 3 minutes. That's 5/3 papers per minute, or per 3 minutes. Now really, we would go ahead and divide 5 divided by 3 because you'd really like to get this in per unit time. But we'll leave it 5 papers over 3 minutes for now. John, what was his? 100 papers in 90 minutes. Need to evaluate why he's so slow. So, alright, so 10 papers on 9 minutes. Okay? So that's his rate. Well, the question then becomes, if you put both of those guys on the same route, what's the length of time it takes them to deliver 100 papers? So you're saying the work rate of David, his delivery, his papers per time, we'll just say the D and the J. Well, we'll just work underneath here. So what was his? 5/3 papers per minute times time in minutes. So the minutes would cancel and it just leaves papers. Okay, plus John's, which was 10 papers over 9 minutes times time in minutes. And so again, minutes cancel. We end up with just papers. So papers plus papers. We want to know when that gets to 100 papers. So let's factor out T sub M. And that gives me 5/3 papers per minute plus 10. Remember, T sub M is factored out. 10/9 papers per minute. And that equals 100 papers. Well, 3, you can have 9 as a common denominator here. We'll just move ourselves up here. So we have T sub M times 5/3 papers per minute plus 10P over 9M, and that equals 100 papers. Alright, so we have 9 minutes is our denominator, so 3 minutes will go into 9 minutes 3 times. So I'm multiplying this by 3/3, so that gives me 15 papers, plus this already is in 9 minutes, so 10 papers. That's time 10, or time in minutes, and that equals 100 papers. So we have 15P plus 10P is 25P over 9 minutes, and that equals, or time in minutes equals 100 papers. So if I multiply by 9 minutes and divide by 25 papers, those cancel out. Now on this side, papers divided by papers cancel. 100 divided by 25 is 4 times 9 minutes, and that equals time in minutes, which is 36. Time in minutes equals 36 minutes. That would be the length of time it would take the two of them collectively to deliver 100 papers. All right, I'm going to stop there, and then I'm going to pause, and then I'll write the next problem, and then we'll be back. So see you in just a few seconds. Okay, we're back. All right, in this case, we have a barrel, has some type of solution in it, and we have two different pumps that can fill the barrel, and we have one pump that can empty the barrel. The rate of fill is 1 barrel in 2 hours. So this pump can fill up this entire barrel in 2 hours. And this other pump is a backup pump, if you will, and it can also fill the barrel, 1 barrel in 2 hours. Now the pump that empties the barrel, it can pump 1 barrel's worth of liquid out in 4 hours. Okay? But the engineer or the maintenance guy that's doing some work here, they for whatever reason had emptied the barrel out, and maybe it had a hole, and they repaired the hole, and now he's filling up the barrel, but he turns on both pumps, but for some reason he left this pump turned on. So now it's trying to fill the entire barrel up with both inlet pumps on, but the outlet pump is on also. So the question is, how long does it take to fill up the barrel in that scenario? So what's the work that's completed and per time? Well, we had, you know, pump 1, we'll call this one number 1, this one number 2, or inlet 1, inlet 2, and outlet 1. So you got the inlet 1 plus inlet 2, whatever their rates are, minus outlet 1. Okay, that equals something about the length of time it's going to take to fill this thing up. Well, what's the work rate of pump the inlet 1? It's 1 barrel. The work performed is I'm going to fill 1 barrel, so 1 barrel in 2 hours. And I can also, with the inlet pump 2, it's also 1 barrel in 2 hours. But we're subtracting this pump that's pumping out. It's 1 barrel. Its work performed is 1 barrel, but how often, or what's the rate at which it does that? It's in 4 hours. Well, let's just get a common denominator here of 4 hours. So 2 hours goes into 4 hours 2 times. If you said 2 hours times 2 hours, that's 4 hours squared. That's wrong, okay? 2 hours goes into 4 hours 2 times. So 2 times 2, 2 over 2. So 2 times 2 hours is 4 hours. 2 times 1 barrel is 2 barrels. Plus 2 hours, same scenario here, another 2 barrels. Minus 1 barrel in 4 hours. Okay? So what do we have? We have 2 barrels plus 2 barrels minus 1 barrel is 3 barrels in 4 hours. The amount of work that's performed is 3 barrels. The time at which it performs that work is 3 hours. Now we have a ratio here. Recall the time we've talked about ratios. It's saying 3 barrels is to 4 hours. In other words, 3 barrels equals 4 hours. Now, the question that we're trying to answer is the length of time that it takes to fill up 1 barrel. So if I have this scenario, if I divide both sides by 3, 3 divided by 3 is 1 barrel. So I'm left with 1 barrel equals 4/3 hour. Well, what is that? That is 1 1/3 hour. What's a third of an hour? Well, 20, 40, 60 is 20 minutes. So this would be 1 hour and 20 minutes would be the time that it takes to do the work of filling 1 barrel. So that would be the answer. Okay, these are just a few quick snapshots of work rates. And as I mentioned on the other problem, it's usually better to get this into, go ahead and use the calculator if you will, get it into work per 1 minute or work per 1 hour. So we would call that work per unit time. And that will make it a little bit easier for your calculations. Okay, that's all for now. Why are we doing this? Together we're trying to build a better tomorrow and do that through math. Study, guys. Keep studying. Work as many problems as you possibly can. Grow your mind, okay? That's all for now, and we'll talk to you next time. Thanks.